The first colligative property is called RLVP, or relative lowering of vapor pressure. See, we have already discussed that whenever a non-volatile solute is added, like a solid solute is added to a volatile solvent or liquid solvent, what happens is the decrease in the vapor pressure of the solution takes place. As we know, we have done already, if that PS will be equal to what? P naught A XA, as I have explained it to you earlier, that since we know that PS will be equal to sum of PA plus PB, and there is no B in this case because your solute is a non-volatile solute, it's a solid solute, it's not going to volatilize easily. So we have only PA, and as per Royd's law, we know PA is equal to P naught A XA. That's why what we get is PS is equal to P naught A XA. So it is the case when we have what? A volatile solute added to what? A non-volatile solute is added to the solution, in the solution, which is basically is a solid liquid solution. Now, in such cases, we can modify this formula like this. We can write PS or upon P naught A equals to XA. Definitely we will prefer to express mole fraction of the solute in the solution rather than the mole fraction of the solvent. So we write this as 1 minus XB. So what we do is we bring value here, we bring this whole term here. What we get is this is 1 minus PS upon P naught A equals to XB, or this term then can be written as P naught A minus PS upon P naught A equal to XB. This is what is your formula is for the relative lowering of vapor pressure. How? You can see here in this formula, the numerator, this one is basically talking about the lowering of vapor pressure, because P naught A was the original vapor pressure of the pure solvent and PS is the solution's vapor pressure. Suppose original vapor pressure of the solvent was your around 200 mmHg. Now after adding the non-volatile solute, this becomes your 140. So 200 minus 140 is going to give you the value, by how much value the lowering has taken place. So this is the lowering of vapor pressure. Now once it is divided by P naught A again, this whole term, the left hand side becomes what? Relative lowering of vapor pressure of the solution. So this relative lowering of vapor pressure is also written as delta P upon P naught A equal to XB. So we can write the relative lowering of the vapor pressure of the solution having a non-volatile solute in a volatile solvent. It is equal to the mole fraction of the solute in the solution. Always this relative lowering will be equal to the mole fraction of the solute in the solution. Let us see the formula of the RLVP, how it can be modified. We know it will be P naught A minus PS upon P naught A equal to XB, which is actually the mole fraction of the solute in the solution, which can be written as NB over Na plus NB. Now see, the main purpose of studying these colligative properties is to find out the molecular masses of these solutes which are dissolved in the solution. See, we know that the molecular masses are the very fundamental basic properties, and without knowing the molecular mass of the solid or of any substance, you cannot find out its chemical formula and then its structure. So the most important step is determining the molecular mass. And there are 4 methods which has been discussed in this chapter, and the basic idea of studying these 4 colligative properties is to know that how the molecular masses of the solutes, which are actually a non-volatile solutes, which forms the solutions in the volatile solvents, can be determined by using these 4 basic properties which are called colligative properties. So let us see from this formula how we can find out the molecular mass of the solute. We can write down this formula as P naught A minus PS upon P naught A. We can find out the number of mole as WB MB upon WA MA plus WB over MB. So this is what exactly you have. and from here we can find out this Mb or this Me, because that is what is the molecular mass or molar mass of the solute, which we want to know from these colligative properties. Now, for dilute solutions, what we do is, for dilute solutions, since the Nb is very, very small in comparison to A, therefore Na plus Nb is always taken as equal to Na. Then therefore your formula becomes P naught A minus Ps upon P naught A, it will become Nb over Na, because from here we will only put from Na plus Nb in place of this one, we will put only Na. Nb is neglected because it is very small. So we can write it will be Wb Mb Ma Wa. So we can use this formula, but only when we have what? Dilute solutions, to find out the molecular masses of the solutes through RLVP colligative property. How RLVP is used to find out the molar masses of the unknown solutes or the solutes which are present in the solution, this we can see with the example of this numerical. The numerical is the vapor pressure of benzene drops from 0.9 bar to 0.88 bar when 0.5 grams of a non-volatile solute is added to 39 grams of the benzene. Find the molar mass of the solute. We know the formula that for dilute solutions, P naught A minus Ps upon P naught A will be equal to Nb over Na, which can be written as weight of solute, molar mass of solute, molar mass of solvent upon weight of solvent. Now from the given data we already know that the vapor pressure of the pure benzene was 0.9 bar. It drops to the 0.88 bar value when it forms a solution. So Ps is your 0.88 bar, and weight of the solvent is 39 grams as it is given here. Benzene C6H6 will have a molar mass of 78 grams per mole, and we know the weight of the solute given is 0.5 grams. So we can use all this data given in the formula, and we can find out that the answer comes out to be, let us see here, it will be 0.9 minus 0.88 upon 0.9 equals to 0.5 by the molar mass of the solute, because this is what we have to find out, into 78 upon 39, because 39 was the mass of the benzene taken. So it will be twice, and this will come out to be 0.02 upon 0.9. It will be 1 by molar mass, which comes out to be Mb to be 0.9 upon 0.02. So it will be 90 by 2, which is 45 grams per mole. So this is what is your answer is, that the answer or the molar mass of the solute is found to be 45 grams per mole. So this is how we can find out the molar masses of the solutes, and this is how we can use the RLVP formula.